This video is going to review the motion test review worksheet. This will help prepare you for your test. Here are the answers to 1 through 8. So these units, you had to say what the unit could be describing. So you can pause the video here and just check your answers for those. All right, number 9 here asks to create a graph that shows a runner in a race. It's a distance time graph. The runner gets off to a very fast start. So here's a slope showing a fast pace, nice steep slope, and then has to stop. So on a distance time graph, a flat line like this means that the runner is stopped, maintaining the same position over time, and then runs at a moderate pace to finish the race. And then we want to assume the race is a loop. So the runner starts and ends in the same place. So if the runner starts at 0, they're going to end at 0. So once they hit halfway through the race, they're going to start coming back towards the start line. The moderate pace has a less steep slope than the fast pace. All right, number 10, looking at, this is a different type of graph. It's a speed time graph. So 3 intervals that the bus is accelerating. Accelerating means speeding up. So that would be from 0 to point A, also from point D to point E, and then also from B to C. That technically, that's an acceleration as well. It's just a deceleration. So the bus is getting slower. So that counts too as a deceleration. Which 3 intervals is the bus moving at a constant speed? So the speed is not changing. That would be from A to B, C to D, E to F. And then again, deceleration is from B to C. Number 13, 3 ways that a car could accelerate. Accelerate means to speed up, slow down, or change direction. The difference between speed and velocity is that velocity is a vector, speed is not. So that means velocity includes a direction. So if I'm driving on 95 north at 60 miles an hour, 60 miles an hour is my speed, 60 miles an hour north is my velocity. And then when do we use an acceleration of negative 9.8 meters per second squared? That is the acceleration of gravity. That is g. And we use it anytime an object is falling through the air or being thrown up through the air. It'll experience that acceleration of gravity. So when you see words like falling, dropped, thrown, those are key words to let you know you need to use your acceleration as g. All right, on the back, analyze the path of the football player. The total distance traveled by the player is just all the amount of space that he covered. So if he started here and went, well, he started here and he went 50 meters up, 30 meters down, 80 meters total. Distance does not take into account direction, but displacement does. Displacement is just a straight line from where you start to where you finish. So if he started here at 0 and ended here 20 meters north of where he started, then that is his displacement. So it doesn't matter what he did in between. A is your answer there. All right, Alicia's feeding the snakes. She starts at Bruce's cage, travels to Homer, and then to Ruby, and then back to Homer. So each one of these cages is 10 meters that she's traveling. So she travels 10 meters, 20 meters, and then back 10 to Homer. So for a total of 30 meters. And it took her a total time of 15 minutes. You're asked to find average speed, average speed is the total distance over the total time. 30 divided by 15 is 2 meters per minute. How much time is an unknown, does it take for a bird traveling at a constant velocity of 45 kilometers per hour? There's V. To travel a displacement of 1,800 kilometers. Displacement is delta x. If the bird has a mass of 0.08 kilograms, how much momentum does the bird have? So you're looking for two things here. You're looking for time and you're looking for momentum, P. So you're going to solve for these two things one at a time. If I know V and delta x and I need to find T, this is the equation I'm going to use. We'll need to rearrange it to solve for T. And then we can plug in what we know. So T, if you're rearranging this equation, you multiply by T on both sides. And then you'll have VT equals delta x, and then you divide by V. So delta x over V. Delta x over V, 1800 over 45 gives us 40, and the unit is hours because it's time, and the speed or velocity was in hours. For momentum, momentum is P, mass is M, velocity is V. So you have the mass times the velocity to give us 3.6 kilograms times meter per second. Number 20, a car sitting at a red light. That means the car's initial velocity is 0. The light turns green, the car accelerates to 50 meters per second. Meters per second is a velocity, so that's going to be your VF in 8 seconds. What is the acceleration? A equals VF minus VI over T. VF was 50, VI is 0, time is 8. So 50 over 8 gives us 6.25 meters per second squared. A ball is thrown upwards with an initial velocity of positive 9.6 meters per second. So here's the picture, ball going upwards, an initial velocity of VI of 9.6. I see the word thrown, so I know the ball is going to experience G, an acceleration of negative 9.8 meters per second squared. At what time will the ball reach its maximum height? That's another kind of hidden variable, is you have to know that at the max height, the velocity is 0. So the ball starts at 9.6 meters per second and reaches a velocity of 0 at the highest point. So we're going to call that VF. So I'm going to use my free fall equation and rearrange it to solve for T. So I end up with VF minus VI over T. I subtracted the VI and then divided by G. So I end up with 9.6 divided by negative 9.6 divided by negative 9.8. It's about 1 second. And the last one, Gaston falling off a cliff. He's fighting with the beast. So he falls. That means he starts with an initial velocity of 0. And the word fall indicates that we need to use G, negative 9.8. And we're given a time, 5 seconds later. So we're looking for VF. We don't even have to rearrange the equation this time. We can plug in 0 for VI, negative 9.8 for G, and then 5 for T. So you get negative 49 meters per second. So for each math problem, you make sure that you list out the variables. That'll help you select the right equation. Rearrange the equation if you need to. Plug in your values. Give an answer with the unit.